So the project I'm talking about today is understanding how the deterioration of cast iron pipes evolves into leakage. We have to halve leakage by 2050. It's a project that's been carried out by a PhD student from Sheffield University.
Delivering this project through PhD will actually allow us to build a stronger evidence base on how cast irons affect asset performance and also what challenges or what strategies can be implemented to ensure that we are managing them effectively.
It's really challenging because our pipes are buried a metre below the ground and we've got to work out which ones are leaking and which ones aren't. We don't want to be digging holes in the road where there's no leak. So what this study will do is it will allow us to focus our efforts better in finding those leaks. As a result of this, we have a far better understanding of what's going on with our cast iron underground, and we can start to make better decisions about which pipes we replace in order to make sure we hit the demanding target of halving leakage by 2050. We've known empirically what happens when you reduce the pressure for some time. You drop the pressure in an area and immediately you notice a lowering of leakage because any holes that are in the pipe will run at a lower pressure. But what we've always seen is a bounce, is that you drop the pressure and the leakage will go down, but then it slowly starts to climb again. And we weren't quite sure what the mechanism was for that. What this report indicates is that we can understand that mechanism. Is that what's happening here is that as we drop the pressure, those leaks, those small leaks, close up because you're reducing the stress upon the pipe. But the hole is still there and it's going to continue to grow, and it will continue to grow as a result of the lower cyclic pressure until it reaches a state where it just stays open the whole time and then starts leaking fully again. So it's actually helped us understand something that we saw empirically and give us an actual theory behind why that occurs. So our customers want clean water when there's leakage occurring in an area. Firstly, that's going to drop the pressure locally in an area. It's making poor use of our resources. We're having to take water out of the environment. It's poor use of energy. We're moving water around that's just leaking as well. And in the long term, it's really going to cause issues with supply demand. By finding leaks faster and by replacing the leaking pipes quicker, what that does is it helps our customers because they will see immediate benefit. Their pressure won't be going down so low, and they'll see long-term benefit as well, because it means that by 2050, we'll have met those demanding targets to halve leakage. So what this study will do is it will allow us to focus our efforts better in finding those leaks. We know as a result of this study that leaks are more likely to be open at night. So therefore that will help us to focus location techniques and say, right, okay, we know that listening at night, you're more likely to see those small cracks opening up and providing sound. What it also does is it drives long-term process as well. So if in the short term we can find our leaks faster, in the long term, it will help us drive better replacement policies because we now start to understand which mains are most susceptible. We can look at the cyclic pressure that main is experiencing and say this is what that's going to be doing to those cracks in those areas. It will help us understand, as we drop the pressure in an area, what that will do to the leakage in the area as well. And so it helps our longer term investment program as well. And it means, for the general public, is that we dig up the right roads to replace the right mains.